In our first example, we have a 3 ohm. In our first example, we have a parallel circuit that consists of a 6, a 10, and 3 ohm resistor, and we're told that 8 amps of current is entering this branch. So in general, the first thing we're going to want to do is set up these proportionalities. So 10 is the largest resistor, so I'm going to put that in the numerator for each branch. And in the denominator, I'm going to put the resistances of those branches. So 6 followed by 10 followed by 3. And if I divide those out, the ratios, the proportions are 1.67 for the leftmost branch, 1 for the middle branch, and 3.33 for the rightmost branch. I'm going to assign an x to each of those to represent the current that's passing through those branches. And I'm going to sum all of those and add them to my total, which we know is 8 amps. And now I can solve this algebraically. So 6x equals 8. Dividing both sides by 6, I know that x is simply 1.33 amps. And now I can go ahead and I can find the current in each of these branches. In the first branch, it's 1.67 times x, which x being 1.33. So that tells me that 2.22 amps will go through that first branch. I know that in the second case, it's simply just 1.33 amps because it's just 1 times x. And in the third, it's 3.33 times 1.33 to give me a total of 4.43. So if you look up at the circuit in the top left, that tells me that 2.2 amps will travel through the 6 ohm resistor, 1.33 amps will travel through the 10 ohm resistor, and 4.43 amps will travel through the 3 ohm resistor. And then we'd be able to go further ahead with this, but we'll see how we do a more comprehensive problem once we've practiced a few of these. But Kirchhoff's rule will be very beneficial in simplifying some complex circuit mathematics.